Going to be talking all about probability. In 5.1, we're just doing the basics, and this is the stuff we should already kind of know about. So probability of an event is the proportion of the times the event occurs divided by the number of possibilities overall. The next thing we want to talk about is the law of large numbers. So let's say I'm doing a probability experiment and I'm flipping a coin. Now, we know that flipping a coin, the probability of getting a heads is 1 out of 2. But if I just flip a coin 10 times, am I definitely going to get heads 5 out of 10 times? No. But if I keep doing that experiment over and over and over and over and over, if you keep repeating it again and again and again, the proportion of times that a given event occur will eventually approach, and this should say theoretical probability. So what ends up happening is the experimental probability ends up approaching, or it approaches, the theoretical or empirical. I can't spell empirical. Empirical probability. So if I just do it 10 times, I'm not going to get 5 out of 10. But if I flipped a coin 1,000 times, it's going to get closer to being 1 out of 2 times, 50% of the time. Okay, the next thing, vocabulary we need to talk about is the sample space. The sample space are all the possible outcomes of a probability experiment. So let's say we're rolling 2 dice. And we want to find the sample space of rolling the 2 dice. Well, that means we need to list out all the possible outcomes. So I could have a 1 and a 1. I could have a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. Or 2 on the first die and 1 on the second, because that is different than 1 on the first and 2 on the next. So those are 2 different occurrences. So we can have a 2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, 3 and a 1, 3 and a 2, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6. Then it'd be a 4 and a 1. And this is kind of monotonous, I know. 4 and a 4, 4 and a 5, 4 and a 6, 5 and a 1, 5 and a 2, 5 and a 3, 5 and a 4, 5 and a 5, 5 and a 6. The last one would be getting a 6 on the first, and so forth. And by listing these out, we can end up answering a whole bunch of probability questions. And I meant to add these questions in, and I didn't. So I'm going to kind of add them at the bottom. How many possible outcomes do we have? Well, we have 36 possible outcomes. Let me add some questions in here, and I'm going to use some notation. So we're going to do a sub question A. What's the probability of getting the same number? So getting the same number on both die. So when we're talking about the probability, we want to know the number of times that happens out of the total possible. So how many times do we get the same number on both of them? Well, that's 6 out of the 36 total, which you can reduce that to 1 out of 6. What about the probability of both numbers being odd? So here's a definite example of when having them listed out really does help. So both odd. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 out of 36, which would be 1 out of 4. What's the probability of getting an even on the first and an odd on the second? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you list them all out, sometimes you can just count. And that's why a sample space could come in handy. Now, I do want to note that probabilities are always going to be between 0 and 1. If I got a probability of 0, that would be like probability rolling a 7 on one die. That's never going to happen. So if you get the probability of 0, that means it never happens. The probability of if you got a probability of 1, that means it's going to happen every single time. So your probabilities are always going to be between 0 and 1. Okay, a women's purse comes in blue, yellow, or white. The purses have either a silver lining or a black lining on the inside. Use a tree diagram to determine the number of different purse possibilities. So let's look at what a tree diagram looks like. So first off, the purse could either be blue, yellow, or white. So tree diagram just means we're going to use a visual aid to help us list out all our possibilities. So the first decision is the color of the outside, blue, yellow, or white. Now within each of those, it could have either silver or black lining. So if it's blue, it could have silver or black. If it's yellow, it can also have silver or black. And then silver or black. This is called a tree diagram because it kind of resembles a tree. And it also helps us determine the number of possibilities. So 1, 2, 3, 4, 5, 6. We have 6 possibilities, possible outcomes. So these are 2 different ways of finding your sample space. Now we've already kind of introduced finding probability. It's the number of outcomes of that event divided by the number of total outcomes. Find the probability that an odd number comes up when a fair die is rolled. That's pretty easy. So if we just roll one die, it's either a 1, 2, 3, 4, 5, or 6. The probability of getting odd would be 3 out of 6, or you could write it as 1/2. So probabilities are simple probabilities are fairly easy. You just count up how many ways it could happen divided by the total possible.